Hello and welcome to this video, and we are going to be talking about graphs in this video, and we're actually going to cover quite a bit of information. If I was you, I'd print these handouts out and take lots of notes. You may need to pause the video or re-watch the video. We're going to go through it quickly, but just remember you can always stop and slow things down on your end when you need to. So we have done this type of skill before, but we used 0 in a previous video. So we are talking about greater than or less than, but now we're going to put in a different value. So what we're going to do here is look at this -3. So I'm going to go ahead and draw a line across at -3. So it'll be somewhere like right through here. Okay. This is your y equals -3 line. And then we want to look at the graph and determine when it is above this line that we just drew in here, this -3, or below it. Okay, so let's get the highlighters involved here. So when we are doing this f of x is greater than -3, that's going to be this loop up here. Okay, and this part here, and these are where we're above, okay, above that line. And remember, you use your x values to state the intervals. So this first loop here, okay, my x value is -5, so -5 comma 2. Okay, if you look, follow it over, your x value at this spot here is 2. Parentheses on both because we're just greater than. We're talking about above, okay? So we're not actually on the line. We're above it. Union, parentheses, and then we're going to do this last piece over here. Your x value is 6, and that goes to infinity, okay? All right, when we change to this greater than or equal to -3, what we're doing is now saying we can be on the line. So let's switch to a different color. So we'll go to this green. So now we're going to add in these spots where we're actually on that line in addition to the yellow that one. So it'll be bracket -5 to 2, bracket, union, bracket 6 to infinity, because now we're including these spots right on the line, okay, and that gives us a bracket rather than the parenthesis. Okay, let's switch to a different color. Let's go orange. Okay, so less than -3 will be this spot down here and this loop down here, and now we need to put those parts of the graph in interval notation. Bear with me, I'm trying to look at 2 different computers at one time, which is not easy for me to do. Okay, so we're interval notation will be -infinity to -5, parentheses, union, parentheses 2 to 6. Okay, so let's talk through what we just wrote there. This first interval here, -infinity to -5, is this first orange piece, and since it's going forever, okay, down and to the left, you're going to have that -infinity, and then it comes up to this x value of -5, and then we're done with that part. Then we're switching to this part over here. All right, and we have an x value of 2 to an x value of 6. Now let's go one more color here. Let's say we are going to use, we'll go light blue, okay, for this last piece. Well, now we're going to add these spots in on the axis because we're adding in that equal to part of the problem. So now we're going to have -infinity to -5, bracket, union, bracket, 2 to 6, bracket. Okay, notice you always use parentheses on infinity. okay? But we were able to add the brackets in on those other numbers since we are including those spots on the line, okay? All right, let's move on to increasing and decreasing. Now this slide here is a very formal definition of increasing and decreasing, but if you don't understand this, it's really not too big of a deal. I like to include the formal definition because some students are successful with reading that and understanding it. And you will see things like this in calculus, okay? But what it's talking about is you're comparing two different x values. You can see that. And then you're talking about those outputs, okay? And so you're just talking about when one output is larger than another output, it's considered increasing, and then decreasing is the reverse of that, okay? But like I said, let's just move on to an example, and you can come back to that slide and read it again later if you want to. Okay, so we have this graph here, and we're going to take this graph apart by looking at when is it increasing and when is it decreasing, okay? So let's highlight. Okay, now I do suggest, like at home with your notes, that you do this highlighting like we're doing in your notes. It's very helpful for your brain to see that. Okay, so if we're going to do increasing first, that's going to be this section of the graph. Okay, think about those y values. Those y values are increasing. Okay, and then this section, those y values are increasing. But since we always read a graph from left to right, these other sections here would be decreasing, okay? So we're not going to include those on our increasing. All right, so increasing, which is the yellow part, okay? So let me highlight that. That's increasing. Okay, increasing will be the intervals. Remember, just use your x values here. The -2, 3.93, to this -1, 2.34, union. Okay, then we're going to do this next one. We're going to use this x value here, the -0.285, to this x value up here, 0.713. Okay, and we have represented both of those sections that are increasing. So let's change to a different color. So for decreasing, we'll use green. So that's going to be this section. Think about those y values are going down, 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 down. Okay, this section and this section. Okay, and like if you were on a roller coaster, and just think about, if you started the, goodness gracious, I'll tell you, this computer is going nuts today. If you started your roller coaster up here on the left side of the graph, you would go down, then you go up, then you go down, then you go up, then you go down. Okay, so we always read from left to right and just think about, if it was a roller coaster, would you be going down or up? Okay, so let's go do our decreasing here. And if you want to correlate your notes together here, you can highlight that, right? So this is our green section. And we are going to represent each of these three intervals using the x values, okay? Now we're starting at negative infinity, and then we're going to go to this x value here, -2.393, union. We're going to do this one in the middle using this x values, -1.234 to -0.285. And then continue it down here, union, that last section, 0.713 to positive infinity. Okay, so when you're doing increasing and decreasing, I definitely suggest you do your highlighting. Go ahead and figure out what's increasing, what's decreasing, highlight those, and then just focus on using these x values, which is a lot easier said than done. Okay, some students will even go through, I'll notice when I'm grading papers or looking at student work, they'll just go through and like highlight those x values just to remind themselves that they should not be using any of those y values, okay? So let's talk about absolute maximum and minimum values, okay? Your absolute maximum values are really just kind of like your highest points on your graph, and your absolute minimum is your absolutely lowest point on the graph, okay? And when you have a complicated graph that has lots of ups and downs, sometimes you can also have what we call a local maximum or a local minimum. Okay, and that's a local maximum would be a high spot for that section of the graph, okay? So it may not be the highest point of the entire graph, but it is a high point for that section of the graph, and you'll notice that it's going to change from increasing to decreasing. And similarly with a local minimum, the graph will be changing, decreasing to increasing. Okay, so let's just go through one. I think it's easier to just see the example than to get too caught up in the definitions. Okay, so let's start with this local max here. Local max. This point right here that I'm circling is a local max. All right, it's not the highest point of the graph, but it is a changing spot, a turning point in the graph, because the graph is increasing, gets to that, and then it's decreasing. Okay, so that is what we consider a local max. All right, and you will say that you have a max value of 2.626, which is that output value, when okay, you have this x value of negative 1.528, okay? And then sometimes they just want you to state the point, okay? But sometimes they'll want you to state it more formally like this. Okay, your local min is going to be this point here. Once again, it's not the lowest of the entire graph. It's just a low spot of that section of the graph, okay? And the graph is decreasing and then it changes to increasing. So it is a turning point of the graph. So you'll say you have a min of this negative 0.226 when that x value is 1.528. Let's go down to the absolute min, and then we'll come back to the absolute max. This is your absolute min right here at this point, and they didn't identify it for us, but that's okay. We can figure it out. This point would have an x value of negative 4, okay, and a y value of negative 6, okay. So just think about the coordinates of that point, and that is the absolute lowest spot on the entire graph, okay? So it is the absolute minimum, and we would say that we have a minimum at negative 6 when your x value is negative 4, okay? Now, absolute max is a little tricky on this one. This particular graph does not have one, so we would say none or no solution. Okay, because the problem is we have an open circle up here. So even though this is the highest point of the graph, the fact that they put an open circle there kind of changes things a little bit, okay? If this was a closed circle, like what you were seeing down here in the bottom of when we did the absolute min, then we could list that point as an absolute max, okay? But since they put that open circle in there, we actually cannot include that, all right? So as a quick recap, local max, local min, you can have lots of those throughout a graph, okay? But an absolute max and an absolute min, you're only going to have one of those, or maybe a no solution, as we had here for the entire graph. All right, so let's get into asymptotes, okay? You've already heard me mention asymptotes in a previous video, and this is your formal definition here if you would like to read it. But it's kind of an imaginary part of the graph, really. We put asymptotes on the graph, but it's really to just kind of help us get the rest of the graph drawn correctly, all right? And it will steer the graph, okay, maybe to the left or the right or up or down, okay? So let's get into looking at some of these asymptotes. Okay, we've got some exponential functions here, and this is your basic f of x equals b to the x exponential function. And each of these have an asymptote at y equals 0. So we have this horizontal asymptote, and I'm going to make it dotted. We typically do make our asymptotes dotted. Okay, it's coming across right there on that y equals 0 line. And similarly on this one over here, we have this horizontal asymptote. Okay, and what it does is it's steering the graph. Okay, you see on this right side, it's flattening out. Okay, and it's over here on the second one, you see on the left side how it's flattening out. So the graph is getting really, really close to that asymptote, but it's actually not touching that particular asymptote. Okay, it's just steering the graph one way or the other. Okay. All right, for a logarithmic function, okay, we have vertical asymptotes. Okay, so these are both your log type function, and we have a vertical asymptote, okay, right on top of this y-axis. So it's x equals 0. Okay, and similarly over here as well, you have one. Okay. And it's steering that graph, okay? You can see it on this left one, it's steering it down, and on this right one, it's steering it up, okay? So we're going to use that as a way to kind of steer our graphs, okay, in the direction we need them to go. Rational functions typically have a horizontal and a vertical, okay? And so rational functions can get kind of complicated. This particular example, there's a horizontal asymptote here on the x-axis. Sorry, this is the this is the x-axis. I was saying it correct the first time. Okay, and there's a vertical asymptote on the y-axis. I'm trying to draw it in here where you guys can see, but it's kind of hard. Okay. And so this is your y equals 0, and this is your x equals 0, and those are our asymptotes that are steering that graph. Okay, so let's do a quick example here and go through some of these. All right, so if you look at this first one here, this is an exponential graph. Okay, if you had to categorize that, that would be an exponential. And you can see it's kind of been moved up a little bit and how it's leveling off at that 5. All right. Well, it has a horizontal asymptote right there at that y equals 5. Okay, and you can see that's being identified down here. And it's making that graph level off, okay, level off at that particular y value. Okay, let's go to the right here. Now, this is a logarithmic graph, okay, if we had to categorize it. And you can see that asymptote is happening right over here on the left, okay, and it is steering that graph down, okay, at that x value of -5. The bottom left, we have a rational function, okay, and we have two asymptotes. We have a horizontal, okay, and we have a vertical, and you can see those have been drawn in for you. The horizontal is at a y equals 10, and your vertical is at x equals 5. All right. Here's another rational graph. Okay, so here's another rational graph. And you can see this one has a lot going on. We have two vertical asymptotes. You can see those drawn in. One horizontal. Your horizontal is at y equals 5. Your vertical, you have one at x equals -10 and one at x equals 10. So you can see how you have multiple vertical, okay, and that's pretty typical of a rational graph. And you also have the horizontal. So quick recap, your exponentials, remember your exponentials are always going to have that horizontal asymptote. Your logarithms are always going to have that vertical asymptote, and your rationals are going to have a horizontal and a vertical. Okay, they're going to have both. All right, so keep practicing. You'll see that this video is leading you into some other activities. Ask questions when you have them.